how the result and the number changes. So we have this in index form as 5 raised to the power minus 2 is equal to 0.04. And second question, we are asked to express 64 is equal to 16 raised to the power 3 over 2 in logarithmic form. This is in index form. So we are asked to express in logarithmic form. So if we express 64 is equal to 16 raised to the power 3 over 2 in logarithmic form, we have logarithm of 64 base 16 is equal to 3 over 2. So the third question, we are asked to evaluate 1 log 1.728 is 1.2. That is, we are asked to solve this. So the first thing we do is we say let logarithm of 1.728 base 1.2 is equal to y. So when we write this out in index form, we have it as 1.2 raised to the power y is equal to 1.728. So how do we go about this? Sorry. Please, some minute. That. So let logarithm of 1.728 base 1.2 is equals to y. Whereas in index form, we have it as 1.2 raised to the power y is equal to 1.728. Now, we can decide to go about this trade-off. You look for the relationship between your base 1.2 and the number 1.728. Or we write out 1.2 and then 1.728 in how should I put it now? Fractional form. 1.2 is the same thing as 12 over 10 raised to the power y. While 1.728 is the same thing as we have this as 12 over 10 raised to the power y, and 1.728 is the same thing as 1728 divided by 1000. Now, we have 12 over 10 raised to the power y is equal to 1728 over 1000. Now we can decide to break this down in relationship with this. When we look at 1728, 1728 is a multiple of 12, and 1000 is a multiple of 10. So we have 12 over 10 raised to the power of y is equal to 1728 is the same thing as 12 times 12 times 12. One is the same. So we have this to be 12 over 10 raised to the power of y is equal to raised to the power 3 over 10 raised to the power 3. So we have this as 12 over 10 raised to the power of y is equal to, since the power are the same, 3, 3. So we can bring it out as a general power. Raised to the power, all raised to the power of 3. So from here, we can say we have equal bases or we equate indices. So we have 12 over 10 raised to the power of y is equal to 12 over 10 raised to the power of 3. This cancels. We have y is equal
Can you hear me?
Yeah.
Okay, you were covering the board.
Hello?
You were covering the board. We couldn't see your workings.
Sorry. So that's that for that. The last question, we have the logarithm of 0.2 raised to like base 625. So in this case, what we do is we say let logarithm of 0.2 base 625 is equal to z. So when we write this out, can I clean the side? So when we write this out in index form, equal to. So when we look at 65 and 0.2, let's break 0.2 down or rewrite in what's it called? In fractional form, taking it away from decimal form. So we have 625 raised by z is equal to 2 over 10. So 2 over 10 will give us 0.2. So we have, when we reduce 2 over 10 to its lowest form, reducing 2 over 10 to its lowest form, we have it as, sorry about my marker. Supposed to have changed it. So we have it as 1 over 5, reducing it to its lowest form. So we have this as 625 raised to power z is equal to 1 over 5, which is the same thing as 625 raised to power z is equal to 5 raised to power minus 1. Now, looking at 625 and 5, we look for the relationship between 625 and 5. When we break down 625, we have it as 25 over 25. I want to write down 625. Breaking down 625. This is 25 times 25. 25 times 25 is the same thing as 5 times 5 times 5 times 5, which is 5 in 4 places, just to show us the workings. So we have 625 as 5 raised to power of 4 in our power of z. So this gives us 5 raised to power minus 1. So when we open our brackets, we have 5 raised to power 4 times z is equal to 5 raised to power minus 1. So we have this as 5 raised to power 4z is equal to 5 raised to power minus 1. So when we equate indices, or equal bases, we have 5 raised to power 4z is equal to 5 raised to power minus 1. 5 cancel 5. Can I clean the side? Can I?
Ruth, can you hear me? Abigail. If you can hear me, unmute yourself.
So we have this as 4z is equal to minus 1. When we divide both sides by 4 over 4 is equal to minus 1 over 4. So when 4 cancels 4, when 4 cancels 4, we have our z is equals to minus 1 over 4. That's our answer. Do you understand? Do you understand? No response.
Ruth.
So I take that as you all understand.
Hello, Ruth. Abigail. Are you there at all? Or you just log in? Please continue. No response for them. Just continue.
Understand? Sorry, please, I'm coming. So we continue from where we stopped last year. So last week we treated laws of logarithm. So let's take example. So the first example, if Let's solve this first of. So last week we treated laws of logarithm, I think 9 of them. So this is an example on each. The first was the product rule. So the first example, which is logarithm of 8 base 3 plus logarithm of 5 base 3 will be the first example for the product rule. Don't forget that last week we said logarithm, the rule states that logarithm mn base a is equal to logarithm m base a plus logarithm logarithm m base a plus logarithm n base a. So now we are asked to solve this, right? Each expression as a single logarithm or solve. So we are to apply this rule to this. Knowing that to write this as a single logarithm, we have to apply what? The product rule, that is, you have to multiply. So we have logarithm, since the base as logarithm of 40 base 3. Do you understand?
Yes, ma'am.
The second question, by given logarithm 28 minus logarithm 14. Now, first off, when you see a logarithm without a base, it is, how should I put it? It is approved or said that that logarithm has a base of 10 automatically. When you see a logarithm without base, so the general rule or the acceptable thing in mathematics is that that logarithm is a logarithm of base 10. So when you see any logarithm without a base, it is a logarithm of what? Base 10. So now, applying the quotient rule to this, we said logarithm of m over n base a is equal to logarithm of m base a minus logarithm of n base a. So if this is the rule, and we have something like this as this, that means we have this as logarithm of 28 over 14. 28 divided by 14 is what? 28 over 14 is what? 14 divided by 28. That's 2. So we have it as logarithm of 2. So we come to the third example. We have logarithm of 2 raised to the power of 10. So we said in our power rule, the third rule was the power rule. When we have logarithm of m raised to power n base a, said it is the same thing as n logarithm of a m base a, n logarithm of m base a. So in this case, where we have logarithm of 2 raised to power 10. So our answer is what? 10 log 2. 10 log 2. That's our answer. So we come to the fourth one. we have logarithm of 3 base 3. So we called this logarithm to its own base, logarithm to its own base. We'll give the example that logarithm of a to the base of a is equal to 1. So we said the logarithm of a number to its own base is always 1. When the number and the base are the same, it is 1. So to solve this, we have it as logarithm of 3 base 3 is equal to what? 1. So the fifth question, which is logarithm of 27 to the base of 9 and half. So this rule applies to the power of the base, power of the base, power of the base. So we said the rule states that when logarithm of base x, sorry, logarithm of x to the base of b raised to power 3. Can you see that?
No, ma'am.
It said logarithm, the rule states that logarithm of x to base b raised to power 3 is equal to 1 over 3 logarithm of x to the base of b. So the power of the base changes to its reciprocal and it comes to the back. So when we apply this, when we apply this formula to the question we are given, logarithm of 27 to the base of 9 and half. So we said the rule states that we have a reciprocal of the base. So and of the power of the base. The power of the base here is half. So what we have here according to this rule is 1 over half, because our power here is half. Don't forget that the power here was 3 and it is 1 over 3. So when we apply this, we have 1 over half logarithm of what? Of 27 to base 9. Now, when we do this, 1 over half is what? 1 divided by half. That's 1 over 1, which gives us 1 over 1 times 2 over 1. This gives us 2 over 1, which is 2. So this one becomes 2. So we have 2 log 9. Now, if not, 9 can be broken down into 3 raised to power 3. So 3 raised to power 7 can be further broken down to what? 3 raised to the power of 3. So we have this as 2 logarithm of raised to the power of 8. Now let's pick it step by step. 2 logarithm of 3 raised to the power of 3 base 9, because 27 is the same thing as 3 raised to the power of 3. So we have this as 2, according to, what is it now? Logarithm of what? 3 base 9. So this gives us 6 logarithm of 3 base 9. Now I want to break 9 down because 9 can also be broken down into 3 raised to the power of 2. So we have 6 logarithm of 3 base 3 raised to the power of 2. Do you understand what I'm doing? Hello?
Yes, ma.
You understand?
Yes, ma.
Do you have any questions?
No, ma.
Okay. So when we apply the logarithm of power of the base here, what we applied here, 1 over to this one, 3 raised to the power of 2. We can't leave it like this because of this 2. So we have to apply the power of base rule to this. So we have 1 over 2. This becomes 1 over 2 times 6 logarithm of 3 base 3. So when we say half times 6, 1 over 2 times 6 gives us 3. So we have 3 logarithm of 3 to the base of 3. Don't forget that the rule of is it power of the base when the number, no, not power of its base, logarithm of its base, I think. Logarithm to its own base, yeah. When the base and the number is the same, that is 1. So we have 3 times 1. Logarithm of 3 to the base of 3 is 1. So we have 3 times 1, which is 3. So that's so continue.
Hello, Miss Godliness. You have about 6 minutes to go.
Wow. Okay. Now, let me solve this. So the sixth rule was inverse rule. We said that a logarithm of logarithm of m base a is equal to m, which is the same thing as logarithm of a raised to power m base a is equal to m. Now this is saying that when we have the rule states inverse rule, logarithm of a logarithm of a logarithm of m to the base of a is equal to m. Now we are asked to solve this. When we apply this rule, it says 2 logarithm of 32 to the base of 2. We have to find our answer. When we use this rule here, applying this rule here, we have it as logarithm of 32 So logarithm of 32, when we break down 32, 32 can be broken down with relationship to 2. 32 is the same thing as 2 raised to the power of 5, 2 in 5 places. So we have logarithm of 2 to the power of 5, there's 2 here, base 2. Now, applying this rule, don't forget that we said logarithm of a the power of m is equal to m. This same m is m here. What's it called? The same. When you have logarithm, your answer gives you this. So when we have 2 logarithm of 2 to the base of 2, it gives us 5. How do we about that? Now we have that applying the logarithm to it, no, not to its own base. Power of the base, is it the power? No, the power rule, yeah. The power rule gives us that logarithm of raised to the power of 5. Now when we bring to the power of 2, base 2. Now when we convert form, let's convert this to index form. What do we have? We have it as, okay, let me keep it explaining of long. Okay, break this down into have it as you know what, let me just stop here today because this will kind of take time and I don't want to stop halfway because I will have to re-explain next week. So let's just stop here for today. I'm going to give you this assignment. Sorry. So find the value of let's just
Yes, ma.
do you have any question? Yeah, I can hear you. Hello?
Hello, ma.
Yeah, I can hear you.
I don't have any question, ma.
Okay. So that's the assignment. We're stopping here for today. We will continue from example F next week. So that'll be all for today.